Good morning children. Today I am going to discuss about the chapter heat. I am R. Aruna, School Assistant Physical Sciences working in ZPHS Kanuru, Penamaluru Mandal, Krishna District. పిల్లలు ఈరోజు నేను హీట్ చాప్టర్లో సబ్ కాన్సెప్ట్స్ ఏమేమి ఉన్నాయి, ఆ సబ్ కాన్సెప్ట్స్లో ఏ ఏరియాని మనం ఫోకస్ చేయాలి, ఆ ఫోకస్ చేసిన ఏరియాలో ఏ విధంగా క్వశ్చన్స్ అడుగుతారు, ఈ సెషన్ కంపల్సరీగా మీకు చక్కగా ఉపయోగపడుతుందని బాగా యూటిలైజ్ చేసుకుంటారని ఆశిస్తున్నాను. ఓకే, లెట్ us స్టార్ట్ ద హీట్. ఓకే, లెట్ us see what are the sub concepts in the heat. Okay, heat, what are the sub concepts? See, thermal equilibrium, heat and temperature, temperature and kinetic energy, specific heat, applications of specific heat, and determination of specific heat of a solid experimentally. This is a very important experiment. We are using principle of method of mixtures to determine the specific heat of a solid. Change of state. In the change of state we can see evaporation, condensation, boiling, melting and freezing. These are the sub concepts we are going to deal with that in this session. Okay. Now let us discuss what is heat. Heat is a form of energy. The SI unit of heat is joule and the CGS unit of heat is calorie. The relation between the calorie and joule is 1 calorie is equal to 4.186 joules. Okay, 1 calorie is equal to 4.186 joules. Okay, now let us discuss what is temperature. The degree of hotness or coldness. The degree of hotness or coldness. The SI unit of temperature is Kelvin. The temperature in Kelvin is equal to 273 plus temperature in degree Celsius. That means we are converting the temperature from Kelvin to Celsius. In the examination they will ask you to convert the Kelvin into degree Celsius or degree Celsius into Kelvin. Let us take an example. If the temperature of the steel rod is 330 Kelvin, what is its temperature in degree centigrade? That means we have to 330, we have to subtract 330 minus 273, we shall get the 27 degrees centigrade. Now let us discuss what is thermal equilibrium. That means the temperature, the heat transfers from a hot body to the cold body, already we know, no? That means up to how much extent it will flow, it attains a common temperature. That means the heat transfers from hot body to cold body until it attains a common temperature. That means when it attained a common temperature, there will be no transfer of heat, no heat flow. That means the temperature is constant. That means here you can see hot body, cold body, the heat is transferring from hot body to the cold body. Likewise, in the examination they will ask you, if a body is at a temperature of A is at 45 degrees and B is at 45 degrees, and what is thermal equilibrium? AB are in thermal equilibrium, A is at 45 degrees and B is at 45 degrees. Okay, you have to expect that there is no heat flow and the temperature is constant. Okay, now let us discuss about a mass. Let us take a test tube. In the test tube, a liquid of mass m1 is there at a temperature T1, and let us take a test tube second test tube. In this test tube, in the second test tube, there is a mass of liquid m2 at a temperature T2. If you mix these two test tubes in a single test tube, what will be the resultant temperature? That means the mass will be m1 plus m2, and the first liquid is at temperature T1 and the second liquid is at temperature T2. What is the resultant temperature? Now for determination of that one, we can use the formula final temperature of the mixture is equal to, that means T is equal to m1 T1 plus m2 T2 by m1 plus m2. in the examination they will ask you what would be the final temperature of 50 grams of water at 20 degrees centigrade temperature and of water at 40 degrees centigrade, that is 50 grams, what is the resultant temperature. Then which formula we have to use? T is equal to M1 T1 plus M2 T2 by M1 plus M2. Now we have to substitute the values. M1 is equal to 50 grams and M2 is equal to 50 grams, T1 is equal to 20 degrees centigrade and T2 is equal to 40 degrees centigrade. Now let us substitute the values. We can get the resultant temperature as 30 degrees centigrade. Okay. Already we learnt what is heat, what is temperature, what is thermal equilibrium, and how to find the resultant temperature if you mix two liquids or two substances, if you combine two liquids also. Now let us shift to the one important bit is there. The average kinetic energy of the molecules is directly proportional to the absolute temperature. This is a very important bit, they will ask you in the examination. Okay. Now let us see. Q is proportional to mass of the substance. What is Q? If you give some heat to a substance, the substance will absorb heat, no? If we cool the substance, the heat will be released from that substance. What is the amount of heat we have to, the substance will be absorbed and it will release when it is cooled down. To calculate that one, we have to know some parameters, that is the amount of heat absorbed or released is directly proportional to the mass of the substance, that is Q is proportional to the mass of the substance. If you increase the amount of the substance, the amount of heat to be given or absorbed or released will be more, that means Q is proportional to the mass of the substance. And again if you see, Q is proportional to the temperature difference. If you, for example, for 30 to 60 degrees we have to increase the temperature of a substance, we have to give some 40 calories. If we want to increase the substance from 30 degrees to 90 degrees, for 60 degrees of temperature rise we have to give more heat. That means Q is proportional to the temperature difference. If the temperature difference is more, we have to give more heat energy, that is Q is proportional to temperature difference. That means Q is equal to M into S into delta T. In the examination they will ask you S is equal to Q by M into delta T, no? In the half mark questions they will ask you some matching questions or reason and assertion on questions like that, no? Matchings and multiple choice also they may give. Then they will give you S is equal to Q by M into delta T, S is equal to Q by M into T, like that they will give some options and they will ask you which is the correct option. So you have to find out S is equal to Q by M into delta T. And also you have to remember that specific heat depends upon the nature of the substance. That means Q is proportional to mass of the substance, Q is proportional to temperature difference, Q is equal to M into S into delta T, S is the constant of proportionality, that is specific heat, no? The specific heat depends upon the nature of the substance, and again I am telling that S is equal to Q by M into delta T, you have to remember this point. And let us do a problem based on Q is equal to M into S into delta T. Here when we have to use this formula M into S into delta T, there is no change of state, only we are increasing the temperature of water or we are increasing the temperature of a gas, there is no change of state. If there is no change of state only, if the temperature increment or decrement, that means if you want to find out the energy absorbed or energy released, the amount of heat absorbed or released, then only we have to use the formula Q is equal to M into S into delta T. Let us take how much energy is absorbed. How much energy is absorbed when 1 gram of water at 30 degrees centigrade heated to water at 80 degrees centigrade. That means we had taken 1 gram, no? That means mass is equal to 1 gram, and what is the material we used water, no, the specific heat of water is 1 calories per gram degree centigrade. Just note down, I am taken mass in grams and also the specific heat in calories per gram degree centigrade, and the temperature difference 80 minus 30, that is 50 degrees centigrade. Then I use the formula, this because there is a temperature increment in the water, Q is equal to m into S into delta T, that is 1 into 50, that is 50 calories. That means the 50 calories of energy is absorbed by the water for the temperature increment for 30 degrees to 80 degrees centigrade. Okay, later we shall discuss these problems also. Okay, now the important topic we shall discuss, specific heat. Already we discussed specific heat, now the constant of proportionality. What is specific heat? The amount of substance, the amount of heat required to rise the temperature of unit mass of substance by 1 unit. You have to note down, by 1 unit. The amount of heat required to rise the temperature of unit mass of the substance by 1 unit, that is called specific heat. Let us take an example. I had taken an aluminum and I had taken iron. An iron rod and aluminum sheet is also there. I had taken for 50 grams everything, and here see I am taking the 30 to 31, that means here I had taken that one 30 degrees to 31 degrees centigrade. That means for the increment of 1 degree centigrade rise, that is the specific heat. Okay. In specific heat, that is, what are the units of specific heat? That is, joules per kg Kelvin is the SI unit and the CGS unit is the calories per gram degree centigrade. In the examination they will ask you what is heat and what are the units of specific heat. What are the units of specific heat? Calories per, yes, gram degree centigrade, that is the CGS unit. Joules per kg Kelvin is the CGS unit. In the examination they will ask you what is the, why the specific heat varies from substance to substance, because we have to know the term internal energy. What is internal energy? Internal energy means the total summation of the energy. There are in between the particles, there will be so many types of energies between the particles, that is rotational energy, vibrational energy and potential energy and the linear kinetic energy. Children, you have to write the substance to substance, the division of the heat energy supplied will vary. Upon this variation, the substance which utilize this energy, the amount of heat energy supplied by us is utilized mostly for the increment of the linear kinetic energy, that will have the least specific heat. That means it will be heated up very nicely, very quickly. That is what in the examination they will ask you, why the substance, the specific heat for the substances vary from substance to substance, why the specific heat varies, like that. Then you have to mention all these types of energies and the substance which utilize mostly for the linear kinetic energy, that will have the least kinetic energy, that you have to write down like that. Okay. Now let us see here. Here see the substances, somewhat their vibrational energy and kinetic energy, like that. No, there are the molecules are moving. No, here you can see this one. Okay. Now let us see. There is an important experiment. How to determine the specific heat of a solid experimentally? For the determination of the specific heat of a solid experimentally, we use the principle of calorimetry. What is principle of calorimetry? Heat lost by the hot body is equal to heat gained by the cold body. heat lost by the hot body is equal to heat gained by the cold body. In this experiment you have to note down what is the hot body, that is lead shots, and what are the cold bodies, that is the calorimeter, stirrer, and water. These are all the cold bodies. So, we can give the information heat lost by the hot lead shots is equal to heat gained by the calorimeter and stirrer and water. Okay? You have to learn and you have to study very nicely. This is a very important experiment. In the physics part, heat is the important, heat is very important for the experimental part. In the physics part, they used to give the experiment also. That is what this experiment is very important in the examination point of view. In everything you have to write the principle, what is the principle we are using for an activity or an experiment. Okay? Now, already we learnt what is specific heat and what are the, how the specific heat vary from substance to substance, already we learnt. Now, a very important aspect, that is applications of specific heat, that is under AS 6 applications. Definitely this is a very important question. I think it may be we may expect the applications of the specific heat or condensation or evaporation in the coming examination. Okay, let us see the applications of specific heat. Let's see, just before giving the information about the applications of specific heat, I want to give you two important points, because if you do not know even the answer, just you can tag up these two sentences. What is those? We shall see. Low specific heat objects gains or loses heat quickly. Just note down this point. Low specific heat object gains or loses heat quickly, and that one, high specific heat object gains or loses slowly. That means the absorption is slow and the release of heat is also slow. You have to note down that point. Absorption is also slow and the release of heat also, it will evolve the heat also, the releasing of heat is also very slow. Okay, now let us see the applications, how they will ask you in the examination. A samosa appears to be cool outside, but it is hot when we eat it. Why? Every day we are eating the samosa, no? And also, why copper is used for the bottom coating of cooking vessels? Likewise, they will ask you, no? Now we can see here a boy is eating a samosa, and here what he feels, we can see the ingredients of the curry inside the samosa is high specific heat. They contain with high, the curry is having high specific heat, and the outer part of the samosa will have low specific heat. That means it loses heat very quickly. Okay, the ingredients of the outer samosa is low specific heat. Okay, the curry inside the samosa will have the high, or already we discussed about this one, no? Okay, low specific heat, and curry inside the samosa will have high specific heat. Okay, this one principle, like that you can put that one and you can write this one. Already I gave two tags, no? You can write based on the answer also. And now we can see why copper is used for the bottom coating of cooking vessels, no? Now we shall see the designing of a cooking pot. See, here a cooking pot is there, and here the handle is with high specific heat and the body will be with the low specific heat, and the bottom will have the low specific heat. Because why? Because low specific heat means it will absorb very quickly. To save the gas and our fuel, we can design the cooking pot with the bottom of the cooking pot with low specific heat. That is the most important. They will ask you in any type of any pattern, but this is the concept you have to remember. The body with low specific heat and the bottom with low specific heat, and the handle with the high specific heat, and lid also with the high specific heat, because we have to touch the lid, no? That is what. Okay. I am giving some questions, likewise they will ask you some other questions also, just think it of like this. Now let us discuss why water is used as coolant. Watermelon brought out from the refrigerator retains its coolness for a longer time than any other fruit. Why? Likewise they will ask some questions. Now we shall see. Here the watermelon is there. In watermelon what will be there? Most of the watermelon contains water. That is a very important aspect of water, is the specific heat of water is very high. That is the most important, you have to remember, the specific heat of water is very high. That is what we have to, so we shall get so many applications based on the property of the high specific heat of water. Remember this, children. And the why water is used as a coolant. In this also the same answer. See here, why we are using? Water has high specific heat. So it will take more time for the absorption of heat. The absorption of the increment of temperature will be very slow. That already we told, no, the high specific heat substances will absorb or release heat very slowly, no. That is what the water is having. Because of the property of the water, we are using the water as a coolant, that is the high specific heat of the water. Children, already we discussed about thermal equilibrium, what is heat and what is temperature, and conversion of heat from Kelvin to degree Celsius, and what is thermal equilibrium. In the thermal equilibrium they will ask you one half mark question also, and also we discussed about what is specific heat, and also what are the applications of specific heat. In the examination point of view, the applications of specific heat are very important, and let us see some more applications of specific heat. Okay. Let us see here. Here we can see the grass house. Why the grass is having, the grass houses are very cool in summer, like that they will ask you, no. Then we can tell the grass will have the high specific heat, and also they will ask you in summer why, when we are living in the coastal area or in the sea areas or river areas, why we are using coolness during summer, and in the winter and in the night time why we are feeling hotness, like that they will ask you. Like, only thing you have to write which substance, you have to identify which substance is having low specific heat and which substance is having high specific heat. Only just identify that one and you have to write down that one. Only that will be the answer. Okay? Do not be panic and just find out that one. Now let us see, how do you appreciate the role of higher specific heat in stabilizing the atmosphere? This is the AS6 question, and this is a very important question also. Here also you have to identify the property of the high specific heat of water. Due to high specific heat of water, they absorb a large amount of heat at the equator without appreciable rise in temperature. That means you have to note down that one. Oceans moderate the surrounding temperature near the equator because of this reason only. Ocean water transports the heat away from the equator to the north pole and the south pole. Likewise, they will ask you how what is the role of higher specific heat of water in stabilizing atmosphere. Then you have to write that question. Okay. Now, in the examination, here there is an important question, AS4 in information skills. They will give a tabular form. Let us see the tabular form, and here substance and specific heat. I will show you a tabular form. Just see the tabular form, and substance, specific heat. You have to see that one, no? Show the tabular form. Yeah, that is one. Very nice. Substance, specific heat, and here there are the values of specific heat and substance specific heat, lead in calories and gram degree centigrade and joules per kg Kelvin also they had given in CGS system and in MKS system. You have to note down one important point. What is that one? If the specific heat is low, the temperature rise will be very high. If the specific heat of is high, the temperature rise will be very slowly. That means you have to note down that one, the first point. In the examination also they will ask you, in a beaker of water, they will put 2 test tubes, and in one test tube they will give, they will pour some water, and in the second test tube they will pour some oil, and they will heat both the test tubes with the same temperature, and they are having the same mass also. In which test tube the temperature rise is high, which test tube the temperature is low, why they will ask you. The temperature of the rise in oil is very high, why the specific heat of oil is less than water. Likewise, they will ask you so many types of questions, they will give some sort of pictures, and they will ask you some questions also like that. In a beaker of water we had given 2 test tubes, no, oil and water. Likewise, in this pattern they will give you so many questions also. Only you have to identify the low specific heat substance will heat up very quickly and it will lose the heat also very quickly, and the high specific heat substances they will gain and the increment of temperature or decrement of temperature will be very rapidly. It will have, if it will have low specific heat, if it is have high specific heat is low, it is very slowly. That the basic important point you have to keep in mind and try to answer those questions. Now I am showing a tabular form now. See here, substance and specific heat, no, already we had given so many values, no, lead, mercury, brass, zinc, copper, iron, like that, no, glass, aluminum, kerosene oil. Just see the tabular form, lead, mercury, and now here see brass and points and zinc, copper, iron, glass, aluminum, kerosene oil, ice, water, sea water. Now so nice, just observe those values. Now I will ask you some questions. Okay, see here, what is the unit of specific heat? Nice. What is the unit of specific heat? Joules per kg Kelvin. Already we learned. Which metal is best for cooking utensils? Why? Copper. Why? Because it has low specific heat. Just you have to go through those values, and since the copper is having low specific heat, it is used for the preparation of the cooking utensils. Okay. The third question, which metal is slowly heated up among all given substance? You have to see, and very slowly means the higher specific heat. Just note down the value of higher specific heat, then write the answer, because they are asking slowly means. Now the next question, how much heat energy is required to rise 10 degrees of water of 1 gram? That means already we discussed about this one, only we are rising the temperature but not the change of state. We had to write down Q is equal to m into S into delta T, that is mass is 1 and specific heat of water is 1 and the temperature increase is 10, that is 10 calories will be there. That means here I had given only for 1 degree centigrade. If you want to calculate for 10 degree centigrade, you have to 1 into 10, that is 10 calories will be there. Now which metal is used to soldering the wires? Why? Lead. Why? Because it is very low specific heat value. It is having very low specific heat value. Okay. That means the copper is having low specific heat value. That means compare that for the metal for the lead also, that is very low specific heat value. Why different substances have different specific heats? Already I told, specific heat depends upon the nature of the substance and the distribution of energy amount of heat given by us will be distributed. Likewise, linear kinetic energy and vibrational energy, rotational energy, likewise potential energy, the substance which we utilize mostly for the increment of linear kinetic energy will have more, that will have least specific heat. Okay. Now, just you do not know that much of information, just you may write specific heat of a substance, depends upon the nature of the substance also you can write, but that it is a little bit answer, but you can't give the total marks. And afterwards write the formula for the specific heat of a substance. Q is equal, that is S is equal to Q by M into delta T. Already all these information we discussed. And afterwards convert 1 calorie per gram degree centigrade into joules per kg Kelvin. Then you have to note down this value. Children, you have to note down this value. 1 calorie per gram degree centigrade is equal to 4.186 into 10 cube joules per kg Kelvin. You have to note down this value. And afterwards, which liquid used as coolant? Why? Water. Why water is used as coolant? Because the specific heat of solid is very high. That is what, that is 1 calorie per gram degree centigrade. We are substituting the value of specific heat in the problems when they are giving the problems. So, now you may understood, they will ask the information in information based questions, or they will ask you predict the reason why it is happening like that, that is in AS2, and they will ask you some sort of a little experiment, 2 marks experiments also. You have, if you are thorough with the information, you can write it very nicely and you can attempt very happily. Now we can see the change of state, the very important concept, change of state. What is change of state? That means every day we are seeing the ice is melting into water and water is evaporating as water vapor, and again we are seeing water vapor into droplets of water in the cool drink bottles. Now we are seeing, no, and again those droplets are freezing into ice, no. Every day we are seeing in our day to life about the change of state. Now we shall see, we shall know the keywords also regarding the change of state. See here, here solid to liquid, the process of conversion of solid to liquid at constant temperature. You have to note down, while the change of state, no temperature will be changed, it will be constant, the temperature will be constant. At constant temperature you have to maintain. Based on this, they will ask you, while 0 degrees of ice is melting to 0 degrees of water, what is the temperature rise? No temperature rise will be there. You have to note down, children, you have to note down this point. Okay? The process of conversion from solid to liquid is called melting. For the process of solid to liquid, the energy will be absorbed, because the kinetic energy of the molecules will be increased, for the conversion of solid to liquid, the energy will be absorbed, but not the temperature will change, only energy will be absorbed. That is what you have to note down. And the process of conversion of liquid to gas, that is evaporation and also boiling, and evaporation. Afterwards we can discuss about what are the differences between evaporation and boiling. Okay? And again, the process of conversion of gas to liquid, that is called condensation. Here we can see, from solid to liquid in melting, the energy is absorbed, and while the conversion in the evaporation and in the boiling, the process of boiling liquid to gas, the energy will be absorbed, while condensation, you have to note down, from gas to liquid, the energy will be released. What is condensation? The process of conversion of gas to liquid is called condensation. And again afterwards, the process of conversion of liquid to solid, that is solidification or freezing, we shall call it as also freezing. In this process also the energy will be released. And again one thing, that directly without going into liquid state from solid to gas, that is called sublimation. Directly, example camphor, like that, no, already we learnt in the 9th class, and again the reverse process of gas to liquid, that is deposition. I will ask you one question, try to understand what is the reverse process of boiling. Yes, that is condensation. That means liquid to gas is boiling and gas to liquid is condensation. What is the reverse process of melting? That means solid to liquid, that is freezing, that is liquid to solid. Likewise, you have to understand when the energy will be absorbed and when the energy will be released. These are all the change of states we are going to study in this session. Okay? Now, we shall see, just recapitulate what we learnt in this one. And solid to liquid, that is melting, that is fusion, and liquid to gas, that is boiling, that is vaporization, also we shall call it as gas to liquid, that is condensation, and liquid to solid, that is freezing, solidification, and solid to gas, sublimation, and gas to solid, that is deposition. Children, just recapitulate what I told, the changes of states and when the energy will be released and absorbed, and likewise. Okay, let us see here. Now, let us discuss what is evaporation. What is means by evaporation? Evaporation means the change of state from liquid to gas. But already we learnt about boiling, no? What is boiling? The process of conversion of liquid to gaseous state, no? Again we are telling that evaporation is also the same thing. What is the difference between evaporation and boiling? This is a very important question they are going to ask in the coming examination. Okay, let us see what is evaporation, what is going on in the evaporation. Okay, that is high energy particles will evaporate and medium energy particles will be pulled back into water and the low energy particles remain as liquid. That means the water particles present in the liquid continuously they will give the energy to the particles which are escaping from the surface. This is a surface phenomena. So, evaporation should be it is a cooling process. That is why evaporation is a cooling process, also in the examination they will ask you. In this session we discussed about what are the applications of specific heat, and now we are discussing about the change of state. We started to learn about the change of state. Children, already we learned about evaporation, no? I think you understood the phenomena of evaporation. Evaporation is a surface phenomena. The particles are escaping from the surface of the water, whereas boiling is the bulk phenomena. That we have to note down that one. Okay? Now let us see here what is there. The differences between evaporation and boiling. Evaporation will take place at any temperature. Just if they ask you the differences between boiling and evaporation and some sort of differences, first of all you have to write down the differences. The definition you can write: boiling, the process of conversion of liquid to gas at the boiling point only. Here evaporation, the process of conversion of liquid to gas at any temperature. This is a quick process and this is a slow process, and this is the boiling is the bulk phenomena and evaporation is the surface phenomena. Here the temperature remains constant, because why? Because this is the change of state at the boiling point. Only water means 30 degrees centigrade. That means 30 plus 273. If they will ask you the boiling point of water in Kelvin also, then 100 plus 273, 373 also you have to write. Okay? At constant temperature, the temperature remains constant, but whereas in evaporation the temperature may change. Here the thermal energy supplied by an energy source, here the thermal energy supplied by the surroundings. From the surroundings only it will take the energy during evaporation. Now this is a very important question. Children, you have to practice thoroughly the differences between evaporation, boiling and evaporation. Boiling takes place at the boiling point only, evaporation takes place at any temperature, and thermal energy is supplied by an energy source. Here the thermal energy is supplied by the surroundings. Here in boiling the temperature remains constant, in evaporation temperature may change. Likewise, you have to see here in boiling there will be bubbles, the water will evaporate like in the form of bubbles, it will go up now, while in the evaporation there will be no bubbles also. Likewise, every day we are seeing these two phenomena, no? While we are heating the water on the stove, we see the when it attains 100 degrees centigrade, we shall see the boiling, and we are putting some cloths, now wet cloths, they are getting dry, then we are seeing evaporation. Likewise, do not be panic, just see the differences, and you are seeing in your day to day life, no, just see those differences and try to write down. Okay. Now let us see applications of evaporation. That is a very important concept, applications of evaporation. In the examination they will ask you one application and what it is going on, or otherwise they will ask you predict the reason what is the for this sort of observation also. Likewise they will ask you, and I will show you some applications. And here you are seeing some wet cloths, no, after some time the wet cloths will dry. Here see, we can see the water molecules are escaping from the surface of the cloths. In the examination they will ask you, when wet cloths dry, you will notice that water in the cloths disappears. Where does the water go? Predict the reason for the disappearance of water. Like that they will ask you, and I will give you some other example. The panting of dog, no, like that, ha ha, like that, no, you can see. Then explain why dogs pant during hot summer days using the concept of evaporation. మీకు పిల్లలకు మీకు ఒక విషయం చెప్పాలనుకుంటున్నానమ్మా, ప్రతి అప్లికేషన్కి కూడా మీరు ప్రతి అప్లికేషన్కి ఆన్సర్ని చదవద్దు. ఇప్పుడు స్పెసిఫిక్ హీట్ అప్లికేషన్కి ఒక కామన్ ఆన్సర్ అనేది మనం రాసుకోవచ్చు. అలాగే అప్లికేషన్స్ ఆఫ్ ఇవాపరేషన్కి ఒక కామన్ ఆన్సర్ అనేది రాసుకోవచ్చు. అప్లికేషన్స్ ఆఫ్ కండెన్సేషన్కి ఒక కామన్ ఆన్సర్ అంటే ఎ లిటిల్ బిట్ ఆఫ్ వేరియేషన్తో మనం రాసుకోవచ్చు. మీరు నెంబర్ ఆఫ్ క్వశ్చన్స్ చదవడం వల్ల మీరు ఫిజిక్స్ అంటే కష్టంగా ఫీల్ అవుతున్నారు. జస్ట్ ట్రై టు రీడ్ ద ప్రిన్సిపల్ and according to the principle what is going to be happened, just note down those issues and try to answer those, but don't try to read all the questions. Yes, applications of evaporation, a common phenomena will be there, some common issues will be there, like this you have to identify. Okay, now see here a part is there, no, the water in the new pot will be cool. Why? If you put some nail polish on your nails, you feels very cool. While we are getting sweat, we shall feel cool. Why? Like that they will ask you. While here we are pouring a drop of spirit on our hand. Take a few drops of spirit on your hand using a dropper. Why does your skin become colder? After some time spirit will disappear. They will ask you why we are feeling cool, or after some time spirit will disappear. Why? They will ask these two questions also in this application. And here see, we are pouring the water on the floor. After some time the water will disappear. In the summer you can see very nicely, when a floor of room washed with water, the water on the floor disappears within minutes. Why? See how many applications. They will ask you some more applications also in your daily life, not these applications only, some more applications also they will ask you. Now I am consolidating all the applications of condensation here, evaporation, sorry, all the applications of evaporation. That means drying of clothes, panting of dog, and a new part, and spirit on the hand, when we poured spirit on the hand, when we poured the water on the floor, and the evaporation of water from the rivers and oceans, like that. What is the answer we have to write? For all these applications of evaporation, which answer you have to write, that is principle evaporation. What is evaporation? Then you have to mention the process of escaping molecules from the surface of liquid at any temperature is called evaporation. Afterwards, evaporation is a cooling process. Why evaporation is a cooling process? Also you have to write, you can write this answer also. Because the particles of liquid continuously give up their energy to the particles that are escaping from the surface. Here again I am repeating, because the particles of liquid continuously give up their energy to the particles that are escaping from the surface. So, we shall feel some sort of coolness. So, evaporation is a cooling process. Again, now you will get some doubt. Already you told for every application we can write a common strategy, we can answer in a common strategy. If I ask why dogs pant, dogs are panting in summer, like that. Then principle evaporation, the process of escaping molecules from the surface of a liquid at any temperature is called evaporation. Because the particles of the liquid present on the tongue of the dog, here we are seeing example about the panting of dog, no, that is on the tongue of the dog, no, because the particles of liquid present on the tongue of the dog continuously give up their energy to the particles that are escaping from the surface. So, we are feeling some sort of cool feeling. So, for the sake of coolness, the dogs will pant like that. If they ask you why the water poured on the floor will disappear, then also you can write principle evaporation and the process of escaping molecules from the surface of liquid at any temperature is called evaporation. And now you can write the particles of liquid on the floor continuously give up their energy to the particles that are escaping from the floor. That means due to evaporation. And now you can't write this also, just the process of escaping molecules from the surface of liquid at any temperature is called evaporation. Due to evaporation, the particles are escaping at any temperature. That means you can write it nicely. If they ask you why we are getting the cool feeling, then only you have to write the second sentence also. If they ask you why the water disappears, why the spirit disappears, why the water present in the ocean it will evaporate, like that. If they will ask you principle evaporation, the process of escaping molecules at any time from the surface of liquid at any temperature is called evaporation. That is nice. Here the water molecules are escaping as a gaseous molecules, like that you can write. If they ask you while the dogs pant, while you are cool, when you kept some drops of spirit on your hand, why you are feeling cool, like that. If they ask you why you are feeling cool, then only you have to write these two sentences what I told you regarding the evaporation and why evaporation is a cooling process. Also I gave the second sentence, no, these two sentences you have to write down. That means for every application of evaporation we can follow a common strategy. If they will ask you some other, no, you write so many applications of evaporation, they asked you one more application, then how can you write? That means first of all you have to understand what the strategy, what is going on in the evaporation and what they asked you. First of all you have to see the question. In the questioning pattern, you have to follow the questioning pattern also. What they asked in the question, what is the process involved, what is the inner process, what is going on. Just based on this, try to write the answers. Don't mug up the answers. For every question you have to write, you have to mug up the answer. Then no, don't try to write the answer. Physics లో మీకు ఒకటే చెప్తున్నానమ్మా, మీరు ఎన్ని పేరాలు ఎన్ని పేజీలు రాశారనేది కాదు, అక్కడ ఏం జరుగుతుంది ఒక కామన్ ఫినామినా తెలుసుకొని కొన్ని ట్యాగ్స్ తయారు చేసి పెట్టుకోండి. అదే ఫిజిక్స్లో ఉన్న టిప్స్. అదే ఇప్పుడు మీరు అప్లికేషన్స్ అన్నిటికీ ఇప్పుడు నేను ఒక చిన్న టిప్ చెప్పాను కదా, అలాగే అప్లికేషన్స్ ఆఫ్ స్పెసిఫిక్ హీట్కి నేను 2 ట్యాగ్స్ చెప్పాను కదా, అలాగే మీరు కొన్ని డెఫినిషన్స్, వాటి యూనిట్స్, ఫార్ములాసు ఒక చోట రాసి పెట్టుకొని, అలాగే అప్లికేషన్స్, ట్రై టు రైట్ ఆల్ ద అప్లికేషన్స్. జస్ట్ వాట్ ఆర్ ద అప్లికేషన్స్ యూ ఫౌండ్ అవుట్, రైట్ ఆన్ ఎ పేపర్. Likewise, you have, because this is the examination time, you have to follow some sort of easy techniques and easy tips also. Don't try to read all the questions, what are there in your given materials or some sort of papers. Okay. Now we can see what are the factors affecting evaporation. This is a very important question. They will, based on this top concept, they will ask you 2 marks experiment also. There are 4 factors, that is temperature, surface area, humidity, wind speed. You have to note down these 4 factors affecting evaporation: temperature, surface area, humidity, wind speed. Now you can see surface area. Now they will ask you one question like this: suggest an experiment to prove that the rate of evaporation of a liquid depends upon its surface area. They ask you 2 marks question. You have to read this one. Don't read these type of don't mug up these type of experiment. Experiment means what you observed. How can you do the experiment? What are the aim, what are the apparatus, what are the procedure, what are the precautions, and what is the principle involved, and what are the observations, and what is the final result. Only you have to know that one. Just here you can take aim to prove that the rate of evaporation of a liquid depends upon its surface area. In the question only that is there, no. And here apparatus we had taken a glass and a bowl, which that vary in a surface area. The surface area of bowl is more and the surface area of glass is very less. Okay. And apparatus and procedure. I had taken 50 ml of spirit or anything, you can write the same substance in glass and bowl, and afterwards I kept aside, and afterwards after 2 or 3 hours or 6 hours I observed there will be a less amount of substance in the bowl. Only that which the because here నేను ఒకటేనమ్మా మీకు చెప్పేది, ఒక ఎక్స్పెరిమెంట్ రాసేటప్పుడు 2 మార్క్స్ ఎక్స్పెరిమెంట్స్కి ఎప్పుడు కూడా చదవాలని పెట్టుకోవద్దు. అందులో ఏ పారామీటర్స్ ఉన్నాయి, ఇక్కడ సర్ఫేస్ ఏరియాని ఒకదాన్నే మార్చాలి, సేమ్ టెంపరేచర్ దగ్గర ఉండాలి, సేమ్ అమౌంట్ ఆఫ్ సబ్స్టెన్స్ దగ్గర ఉండాలి. ఈ కండిషన్స్ అన్ని మిగిలిన వాటిని కాన్స్టెంట్గా మనం చూపించి ఏదైతే మనం మార్చాలో దాన్ని మాత్రమే మారుస్తున్నట్టుగా ప్రొసీజర్లో రాస్తే సరిపోతుంది. అది గుర్తుపెట్టుకోండి. హియర్ ఐ హ్యాడ్ టేకెన్ ఏ గ్లాస్ అండ్ ఎ bowl and the same substance at the same temperature and the same amount of substance, that you have to mention. Then in the observations what you are going to write, the amount of substance present in the bowl is very less because the result. So I confirm that the rate of evaporation of a liquid depends upon surface area. That means if the surface area is more, the rate of evaporation is more. And again, like the humidity also, they will ask you the rate of evaporation of a liquid depends upon humidity. Here we can see, okay, here, and I had taken 2 bowls, the same bowls and same bowls and same bowls and same objects. I kept in one thing, I kept a lid, and then the second one I could not keep the lid also. I had taken away the lid, and afterwards, and it is exposed to the humidity which is in the surrounding atmosphere. Likewise, you can write the aim, that is what is there in the question, apparatus what you are going to take, what is there you are using in the experiment. You can write those experiments. Only you can write the apparatus what you are using, but not the in the textbook those apparatus are there. And for these type of experiments you can write it your own, and you can think it of also, and write the procedure and observation, and what is the observation you can write, and what is the result also you can write like this. And here wind speed, and a fan is kept is there, and same type of bowls and same substance and the same temperature, and I kept for one bowl I exposed to fan air of the fan, and the second substance I could not expose the fan air from the fan, and I kept aside. And what I observed here, what is the aim of the experiment, the rate of evaporation depends upon the surface area, and what are the apparatus, and some 2 bowls with the same substance with the same amount and with the same which are at the same temperature, and a fan. Now you have to write the procedure. I exposed one bowl with the air air from the fan and I kept aside the second bowl without reaching the air from the fan, like that. What observation, what you observe, the rate of the temperature decrease, the rate of evaporation is more when the wind speed is more, like that you can write, and you can write the conclusion what you observed, that the rate of evaporation depends upon the wind speed, like that also you can write. In these 2 marks questions you should not mug up, just write, just think it of what is going on in the experiment and try to write the experiment at your own, but do not mug up. So, this experiment I have to mug up and we have to write and చూడకుండా రాయాలి, చూసి రాయాలి, they are not like that. Just ఆ experiment లో ఏమేమి వాడాలి, ఎలా వాడుతున్నారు ఏమిటి, try to write it your own, that is the aim of the experiment, no. Okay, these are the, okay, here I gave you same amount of liquid exposed to atmosphere for the same amount of time and which are at the same temperature also. Okay, and try to some parameters, what are the parameters kept to be constant, you have to put in your brain, and what are the parameters that are to be varied, అంటే ఏవి మీరు అంటే మనం ఒక ఎక్స్పెరిమెంట్ చేసేటప్పుడు కొన్ని పారామీటర్స్ కాన్స్టెంట్గా ఏమేమి ఉంచుకోవాలనేది మాత్రం గుర్తుపెట్టుకోండి, ఏ పారామీటర్స్ని చేంజ్ చేస్తున్నాం అనేది మనం చూసుకోవాలి. కాబట్టి దాన్ని బట్టి వీఆర్ గోయింగ్ టు రైట్ ద ఎక్స్పెరిమెంట్ at your own. Okay, okay, now let us sum up the factors affecting evaporation. Temperature, by rising the temperature the rate of evaporation also increases, and temperature is also one type, that means a constant temperature I told, no, that for the parameter I kept the constant, if I did not kept the parameter constant, that will affect the surface area also, that means surface, that means affect the evaporation also, that means surface area. The rate of evaporation can be affected by increasing and decreasing the surface area. And humidity, when humidity increases the rate of evaporation decreases, and the speed of wind need kinetic energy to flow. If the speed of wind will be more than the kinetic energy and the temperature will be also more, so the rate of evaporation will be more. Nature of the liquid, and already we learnt about the rate of evaporation depends upon the nature of the liquid, no, that is the interparticle force of attraction. Do not need to study all these issues, only just I am giving for your information, for the sake of information only. Just what is the relation, just observe the relation between the surface area and rate of evaporation, and humidity and rate of evaporation, and speed of wind and rate of evaporation, and in the activity mode you have to present that information, how to do the activity on your own. Do not try to mug up all these experiments as this question, that question, like that, you have, do not be like that. In this session what we discussed, applications of evaporation, and what are the factors that will affect the rate of evaporation, and if in the examination if they asked an experiment, prove that the rate of evaporation depends upon surface area or humidity, like that, how to write the experiment as our own, like that. You already we discussed about the issues. In the coming within 10 minutes, within 1 minute we shall continue that one with the other aspects also. Okay.